In this video I'm going to show you how to find the limit of a trigonometric function that involves expressions like sine of x or tangent of x when x approaches to 0. So first I want to establish the following fact. If you have a limit of sine of ax over x, then that limit is equal to a. How can we prove this? Well, we're going to use the fact that limit as x approaches to 0, sine of x over x is equal to 1. So this is we're going to use as a fact. And using this fact, we're going to prove that sine of ax over x as x approaches to 0 is equal to a. How do we do that? We do it by substitution. So let t be equal to ax. That means x is equal to t over a. That means t as x goes to 0. So the limit now becomes in terms of t, and it is sine of t over a, which means a can be brought to the numerator, and we have limit of sine of t over t, which is 1. So this limit is equal to a. So once we establish this fact, now we can do the original problem. So the limit of tangent 6x over sine of 3x as x approaches to 0 can be rewritten like this. It is sine of 6x divided by x divided by sine of 3x divided by x and multiplied by secant of 6x. So you can double check this, but this entire expression can be collapsed to be to look like this expression. But why do we prefer this expression? Well, because now we can split this limit into 3 limits which we know. So each of these 3 limits is not a big deal to us, starting with secant of 6x. Secant of 6x is just 1. Sine of 3x over x as x approaches to 0 is 3. And sine of 6x over x as x approaches to 0 is 6. So the answer is 6 divided by 3 times 1, which is 2. So this is how we find the limit of a trigonometric function that involves the expressions of the form sine or tangent of some multiple of x.